Now various types of homomorphism. Homomorphism. Number first, monomorphism. Homomorphism F from the group G1 to on the group G2 is said to be monomorphism if the function f is 1 to 1, or the function f is an injective function from the group G1 on a group G2. Epimorphism. A homomorphism function from homomorphism function F from the group G1 and group G2 is said to be epimorphism if the function F from G1 and G2 is an onto function. For example, the set G contain the element 1 minus 1 is a group with respect to multiplication. Let F be a function from Z plus, where Z plus is a group with where Z is the set of all integers and so on. This is a group with respect to the ordinary addition, and F is a function from Z plus on G multiplication, that is on the group G, where the group G is a group with respect to the binary fraction multiplication, defined as f of x is equal to 1 if x is an even number, and f of x is equal to minus 1 if x belong to the Z plus x belong to Z, x belong to the set Z, to the group Z, such that the element x is an odd number. This function is an epimorphism because when we select any two element x1 and x2 from the group Z, and these elements are even number, then the sum of two even number is an even number. That is, if there are two even number 2 and 4, the sum of these two even number is an even number. Therefore, the image of this even number under the given function is equal to 1, which is also equal to 1 multiplied by 1 is equal to 1. Therefore, f of x1 is an even number. Therefore, the image of x1 under the function f is equal to 1, and the image of an element x2 under the given function f is also equal to 1, because x2 is also an even number. Therefore, the function f satisfies the condition of homomorphism from Z on G when the element x1 and x2 are even numbers. Similarly, when we select any two number x1 and x2 which are odd number from the group Z, then the sum of two odd number is an even number. That is, if we select the two odd number, that is 3 and 5 are two odd number, the sum of these two odd number is an even number. Therefore, the image of this even number under the given function is equal to 1, and 1 is equal to minus 1 multiplied by minus 1 is also equal to 1, and minus 1 is the image of an element x1 under the given function f, and minus 1 is also the image of another odd number x2 under the given function f, is defined above. Now, to check the third one condition, that when x1 is an even number and x2 is an odd number, then the sum of the even and odd number, if we select one of the even number, suppose 2 is an even number and 3 is an odd number, the sum of even and odd number is an odd number. Therefore, the image of this odd number under the given function is equal to minus 1, which is also equal to minus 1 multiplied by 1 is equal to minus 1, where minus 1 is the image of an odd number x2 under the given function is equal to minus 1, and the image of an element x1 under the given function is equal to 1. Therefore, the function f satisfies the condition of homomorphism from the group Z on the group G. Also, the image of the group Z under the given function is equal to the whole group G. Therefore, the group G is the function f is homomorphism as well as is an onto function. Therefore, the homomorphism F from the group Z and the group G is an epimorphism. Isomorphism. A homomorphism function F from the group G1 and a group G2 is said to be an isomorphism if the function F is both one-to-one and onto function. That is, the function F is a bijective function. Endomorphism. A homomorphism function F from the group G1 and the group G1 under the bifurcation star. That is, the homomorphism F from from the group G1 and itself is said to be an endomorphism. For example, F is a function from Z plus and Z plus, where Z plus is a group with respect to the bifurcation addition, defined as f of x is equal to 2x for each x belong to Z. Then for any two element x1 and x2 belong to the set Z, f of x1 plus x2 is equal to 2 multiplied by x1 plus x2, which is equal to 2x1 plus 2x2. And 2x1 is the image of an element x1 under the function f, and 2x2 is the image of an element x2 under the function f. Therefore, f of x1 plus x2 is equal to f of x1 plus f of x2, where plus is a binary operation on the group Z, and this plus is a binary operation on the group Z. Therefore, the function f is a homomorphism from the group Z, Z plus on Z plus, and is said to be an endomorphism from the group Z plus on the group Z plus. Automorphism. An endomorphism F from the group G1 and itself is said to be automorphism if the function F is both one-to-one and onto function. That is, the function F which is a homomorphism from the group G1 and itself. Also, the function f is a bijective function. The difference between the automorphism and isomorphism is that the isomorphism is a bijective function from the group G1 and another group G2, and automorphism is a bijective function from the group G1 and itself.